All right, so last week we focused on solving systems of equations by graphing it. So you know when you have the two lines, you graph them, and then the point at which they cross over is the point of intersection, which is also the solution to both equations. This week we're going to look at two different methods of solving these equations. We already looked at graphically. Now we're going to look at how we could do it algebraically by a method of elimination and substitution. All right, but the first one I'm going to do is by method of elimination. So our learning intention states we are learning to use graphical and algebraic approaches in order to solve systems of equations and inequalities in an efficient way. Two success criteria says I will be successful when I can find the solution set for a system using the substitution method, but also finding the solution set for a system using the elimination. All right. We are going to be looking at two different methods. We looked at it graphically. Now we're going to talk about the method of elimination and the method of substitution. All right, so say we have our two equations, and now we want to solve this by a method of elimination. Remember, we're not plotting this graph. We could plot these two lines and see where they intersect, but we're going to solve this algebraically. Just like the name states, this is by a method of elimination, all right? So in order for me to solve this, I need to eliminate one of these variables so that I could have one variable equaling to something else. So it's either I'm going to get rid of the x variables or the y variable, all right? I'm going to do that by just scoping through. Right now I'm going to look and see, which one do I see are related in some way, shape, or form? If I get, how can I make this 3x into a 12x? What do I have to do the 3x to get it to 12x? I look at that and I say, if I multiply this by a 4, I would get a 12x, right? If I multiply it by a 4, I would get a 12x. But I want it to be the same thing as this right here. I want it to be the same thing as the negative 12x. We're going to work several other examples. So this is just the first one. So we'll get some practice with it. So I want to get rid of one of the variables, but in order to get rid of a variable, I need it to be the same. When I say I need it to be the same, I'm talking about a -1 plus 1 would give me 0. So then that's eliminated. So I kind of want to do the same thing. Negative x minus x is 0. So then that x variable is eliminated. So I want to do the same thing whenever I'm solving these systems of equations by elimination. So in order for me to what happened? In order for me to get a variable taken out, so we're basically just canceling out the variable. So with this one, I have to multiply it by a -4. Because if I multiply by -4, this becomes a -12. All right, so if I do that, my new equation states -12, and then I have to do the same thing with the other ones though. So -4 times -4y is positive 16y. Whoops, forgot my x. So that's -12x plus 16y equals, then I have to do -4 times 2, which is -8. So this was my first equation. I like to go in and label my equation. So this is equation 1. And then I went through, and this is equation 2. And then I literally just created a new equation. I'm going to move down my equation 1 so that I could have my two equations side by side now. So minus 12x plus 9y equals 7. And that was my equation 1. All I did was just move it down. Bam. So now I have these two equations, and my process of elimination I'm gonna get rid of these, that x variable. Since they're both the same, now I could get rid of them. I could eliminate it. So you ask yourself, what operation do I need to do to get rid of a negative 12x minus, no, get rid of 2 negative 12x, I'm sorry. What would I have to do to get rid of 2 negative 12x? To eliminate, you always use that subtraction. The process of elimination, to get rid of something, you subtract it. So if they're the same, since they're negative 12x and negative 12x, they're both the same term. All right. So in order to get rid of it, I am going to subtract. I'm going to put a big subtract right here. And I'm going to put this in parentheses so that it's easier to see. Because all I'm saying is this equation minus that equation. I'm going to draw a line. It's like I'm doing this big subtraction problem. So I do negative 12x minus 12x, which is 0. I'm just going to put a dot because it's 0, period. And then I have 16y minus a positive 9y, which is a 5y. Is that a 5y? No, it's not. It's a 7y. And then now I have a negative 8 minus a positive 7, which is a negative 15. My recording. So now, since I've eliminated the x variable, now I have the y variable. So I'm going to divide by 7 using the multiplicative inverse. So y is equal to negative 15 over 7. We just found y, so now we need to find what x is. Keep in mind, again, I did not have to eliminate the x variable first. I could have eliminated the y variable first. It's completely your choice. Does anyone have any idea how I would go back and find the x variable since I found the y? Any idea how I would go back and find the x variable? Yeah, so in order for me to find what the x variable is now, I'm going to take one of the equations. I could take equation 1, I could take equation 2, I could take equation 3, whichever one, it don't matter. Okay, so 2x plus 9y, I'm taking equation 1, is equal to 7. I'm going to say I want you to realize how I write all of this out. Let y equals negative 15 over 7. So then now I'm going to rewrite all of this. 2x plus 9 times negative 15 over 7 is equal to 7. And then I solve. All right. All I did was take the y variable and put it in where it was in the equation. This is equation 1. All right. I'm going to label it equation 1. Thank you for pointing that out to me. This would be a negative 12x. Right here would be a negative 12x. Thank you very much for pointing that out. All right, plus whatever 9 times negative 15 over 7 is, which is negative 135 over 7 is equal to 7. Now I need to do the additive inverse. X is equal to 7 plus 135 over 7. To make this easier, I'm going to change this 7 right here into 49 over 7, because 49 over 7 is the same thing as 7, right? is equal to 49 over 7 plus 135 over 7. Running out of space, so 49 plus 135. Then I could add these fractions because they have the same denominator, which is going to be equal to 184 over 7. And then that 184 over 7, this is what I'm going to do. So now I'm left with, I'm moving it right here so we could see, negative 12x is equal to 184 over 7. And in order to figure out what x is, I would do x is equal to 184. Feel free to put this in a decimal format and then give it 2 decimal places. So 184 divided by negative 12. Because in order to get rid of the negative 12 over here, I divided both sides by negative 12. All right. That's how you kind of do the process of elimination. We're going to do one more example after this. Okay. That's the process of elimination.